Okay, so I'm in the unenviable position of being between you and beer. But I think that means I have your full attention. I hope. So we'll see how this goes. We're going to kick things off by talking about vultures. We'll get there. You just bear with me. I want to tell you a little bit of a story first. So in the early 1990s, a painkiller called diclofenac became available in a generic, affordable form in India. And farmers quickly realized that this generic, affordable form was great for them to be able to use it treating issues of pain and inflammation in their livestock. So they adopted it quickly and universally across India, a country with over 500 million livestock animals. And what no one knew at the time was that even small residue amounts of diclofenac in an animal carcass, like cattle or sheep or others, when consumed by a vulture, will cause kidney failure in the vulture and will kill it in a matter of weeks. So the crisis that followed was historic in speed and scope. The three most common species of vultures in India all died in less than a decade, and the region's primary scavenger became carrion. Quickly, it became obvious to everyone there that India was actually dependent on the vultures to clean up the millions of carcasses. Now, these are livestock animals for the most part. Cattle aren't eaten or consumed in India. They're used to produce dairy and towing things around and whatnot. So the shock of this collapse led to those bodies piling up, carcasses of dead animals. And a public health emergency followed, the depths of which took decades to really begin to understand. This is what happened. So over 5 decades, 100,000 people more died that year than they normally would have had this not happened. So over 500,000 people died as a result of using a painkiller in cows that turned out to kill vultures. So hundreds of millions of people lived in these districts, and a group of researchers got that number, 100,000 extra deaths per year, by studying normal trends and then looking at what they think happened. And they attributed the additional deaths to increased rates of diseases like rabies, as well as decreased water quality due to contamination from decomposing carcasses, including now the vultures. And in addition to the loss of life and death and health issues, the vulture crash was costing India billions of dollars. So the cleanup that vultures had previously done, quietly, I don't know how a vulture's quiet, for free, at least, let's go with, had to be accomplished by newly recruited human crews, vehicles, and expensive new facilities like rendering plants. Pro tip, if you want to sleep well at night, do not Google rendering plants. That was a nightmare for me. So Doss, one of the researchers, and her co-author, N.M. Ishwar, they estimated that each vulture in India was providing between $3,000 and $4,000 in economic value during its lifetime, and likely undervalued. And there were also pollution and climate impacts of releasing greenhouse gases from all of these new factories that had to be built. So why are we talking about vultures? I think you might already be beginning to get a feel of this. This is one example of other similar intertwined cultural and biological agricultural systems. Another one you might have heard of is the Four Pests campaign that led to the Great Chinese Famine in the middle of the 20th century. It's a prime example of unintended consequences in complex systems. By the way, my daughter refers to the 20th century, like the 90s, as the late 1900s. So she's not here, but you're welcome. So I wanted to take this example of complex systems, get your brain thinking about unintended consequences, and we can sort of dive into what this is all about. So this is me. My name is Courtney. Obviously, I've been in the industry for over 20 years at a bunch of places that you might have heard of. And 4 years ago, I started something called The Void. And it's a database of public software incident reports. How many of you have ever written one of those? Maybe. How many of you have ever read any of those? Okay. How have you found them? They're just out there. You hope to go find them. So my first goal was to just collect them all as much as possible into one place. It's not something that we'd ever had before as a resource for us in our industry. And really what I wanted to be able to do was use that to do research and raise awareness and increase understanding of software-based failures, ultimately because it runs our world, right? And the internet is how everything gets done now. We want it to be as resilient and safe as possible. So the void itself is over 10,000 public incident reports. I didn't go and get them. You all maybe wrote them, published them online, and I scooped them up. 600 or so organizations at this point, starting roughly around 2008 up until very recently. I just added a few more today, actually. So they're in a variety of formats, everything from comprehensive postmortems and retrospectives to social media posts, status pages, blog posts. There's even a few like tweets and conference talks. And I wanted everything in there because I wanted to take a holistic look at how we talk about and think about incidents. Okay, so that's what the void is. And in the past, I've done primarily quantitative research on the data that are in there. There's everything you could imagine in there, from the full description of the incident and every other bit of metadata that I can possibly get my hands on. So if it's in a status post and I can tell what the duration is, I'll put that in. Or if the author tells me what the duration is, I'll put that in. If they say that it was DNS and it's not always DNS, I'll put that in. So there's all these metadata that are in there, and then the full text of any incident report. And what I initially started wanting to look at was, my favorite myth for a long time was around MTTR, or mean time to resolve. And I used the data over the past few years to demonstrate how MTTR doesn't tell us what we think it tells us. In fact, it's lying to us, but that's a whole other conference talk. And you can go look those ones up if you want to, or go download the reports. So what I wanted to do was take a look at some of the more qualitative data that we have in the void. So we have lots of text, lots of unstructured text, people talking about what happened. And over the course of lots of folks that I've been talking with, automation is a topic that comes up that I feel like we have a lot of other myths and misconceptions about. And those are the things that I'm really trying to chase down to help us understand how we think about incidents and how we can tackle them and learn from them better. So I wanted to look at what data I could find in the void related to automation. And so the way that we went about this was first to try to come up with a definition of automation. Good luck. I tried, I don't know how many versions with how many people, and nobody agreed exactly on what I said. But it's arguable that automation is everything in software in some way. All software embodies automation. Partly adhering to the common understanding of automation as a substitute for human things. And so I just wanted to come up with a definition of something that encompasses what most people assume automation does. And talking to a lot of folks, it became pretty clear that we think of automation as ultimately use of machines to perform tasks or software, often repetitive, in place of humans. The replacement of humans through automation is the key consistent theme across all of these discussions that I've had with people. And so I worked with that, and then I talked to a bunch of those folks to help me. You'll see I used some keyword searches and things like that to get into that. But first, one more little diversion, because this is not new. I am not a genius. Other people have tried to study this in other domains. And a lot of the direction I've taken in my research has come from research that other people have done, notably in things like aviation, nuclear power plants, control rooms, other places where there's high risk, high tempo situations, complex systems that have a pretty high degree of automation. So an airplane cockpits is a really hot area of that research that's happened over the last many decades. And contrary to prevailing beliefs, what those folks found is that automation often contributes to incidents and accidents in unforeseen ways, and especially imposes unexpected burdens on humans who are responsible for overseeing or interacting with it. So a lot of this comes from some early theories about cognition from researchers in the mid-late 1900s. And this is the Fitz list, these sort of two pieces of this. And it's based on the work of Paul Fitz. He was a psychologist and researcher at Ohio State, among a few other places. And so that's named after him. The other way that you might have heard this is HABA, MABA, humans are better at, machines are better at. For a long time it was men are better at, machines are better at, but we moved past that one a little bit at least. And this idea is that there are functionally allocated tasks based on the strengths and weaknesses of those two things, right? Machines, software, and humans. And so you sort of have this set of things that humans are really good at compared to machines, and then vice versa. And they're like mutually exclusive somehow. And anybody who probably works in these kind of environments realizes that's probably not true, but this is one of those conceptual frameworks that has guided a lot of the way that we put automation into our systems. And more recently, this notion has been called functional allocation by substitution. If any of you are familiar with the work of folks like Sidney Dekker or David Woods or Eric Holnagel, these are all folks who are cognitive human factors researchers, promoting the idea that, or trying to tackle the idea that we can simply substitute machines in for the place of people. And so this substitution myth really relies on that belief that we have fixed strengths and weaknesses, and therefore all we have to do is functionally allocate those tasks to each agent according to their strengths and their weaknesses. And we tend to proceed with designing automated systems, deployment pipelines, CI/CD, load balancing, all of that, without examining the consequences of this approach, of this conceptual framework. And I mentioned Dekker and Woods identifying a number of, as researchers. They wrote a really great paper in 2002 that doesn't have any of the text on it. Oh, wait, hold on. I know. I ought to, see. When these things get in the way. So they have 4 main points that they bring up. I forgot that I put an animation on this, y'all. So of the ways in which that automation, designers of automation and the ways that we think about automation impact how that works. And so in software systems, you'll often see examples of this where we expect something like, your CI/CD pipeline to, quote unquote, and I quote this because I literally pulled this out of a report, out of someone's incident report, reduce the number of errors that can take place in the many repetitive steps in CI and CD, right? I mean, that's a big reason why we want to do those things, right? But we don't tend to have app-specific dashboards and things that surface the internal state of programs. Like, what does the automated process think the state of the world is? What is it trying to do? I mean, how many times have you just been like, what is it doing? I don't know. It's scary. Another researcher, Nadine Sarter, calls these automation surprises. And this kind of, not having this kind of view is very problematic for us when dealing with automation that acts independently and running autonomously all the time, like load balancers or orchestration systems, right? The third thing that they sort of point out is that this functional allocation creates new categories of things that we have to deal with. It transforms people's work and forces them to adapt in novel and unexpected ways that weren't thought of by the designers when they came up with the systems. I mean, if you've ever not known which dashboard to check when all the lights go red, this is exactly what I'm talking about. And if you have to dig through logs, I mean, you're very familiar with this phenomenon. And this can often lead to pockets or silos of expertise. So when Amy the Kafka wizard isn't around, no one knows how else to figure out what's going on or why. Because that one person has that really in-depth, in-person experience with that system and kind of understands the ins and outs. But the rest of us, we don't. And so it creates these new human weaknesses, if you will, that then have to be folded into how that system's going to work. And this last one is what really is encompassed in one of my favorite bodies of research around all of this, which is Lisanne Bainbridge's Ironies of Automation. And I apologize, all of my references are cultural American references, and they're all from the late 1900s. So bear with me, y'all. That's Alanis Morissette, who wrote a very famous song in 1995 about irony. We all know she was kind of wrong about what's ironic. But in the driver's seat with her is Lisanne Bainbridge, who did this research and published it back in 1983. Okay, so the Ironies of Automation, this paper that she released then, before we were all computering, before maybe some of you were alive. She was, she's still alive, but in her work, she was a cognitive psychologist, active in human factors research, and she did a lot of her work on process controllers and went on to conduct research on things like mental load and process operations. Her work was based primarily on direct observation of experts in other domains, notably aviation. And I'm going to give you 4 of her ironies. That doesn't mean there's only 4. It's a little more complicated than that, but we have 35 minutes. So the first one that she identifies is that humans are the designers of automation, yet their designs often have unanticipated negative consequence for the humans interacting with that automation. The second one is when automation does fail and humans have to take over, they often lack the knowledge or the context to do so. So that's because proper knowledge of the system and how automation works within it requires frequent exposure to it operating in a variety of scenarios. And this kind of knowledge only develops via practical, hands-on feedback with the system. And so really, the irony here is that we're asking like the people with the automation to like monitor the monitoring, right? And then how do you know? And that's sort of like monitoring turtles like all the way down, right? The third irony was that when things fail, and we know they will, often the scale of the tasks you have to do is much greater than was imagined for what that automation was designed for. And so this creates new, unexpected work for the people because the designers can't fully automate the human parts. The human is left to cope with what's left after the automated parts don't behave as expected, sort of leaving more complexity in their wake. I don't know if anybody had seen this video of the like catering cart that went rogue. And so, and then the last one is that we tend to design automation and expect the humans will just sort of watch what's going on, and we give them run books, right? Okay, well, like if things are wrong, check this, check that, and check this other thing. This is Homer Simpson, if you've ever seen this episode. He says, it's as big as a phone book. But they can't cover all the possibilities, and they're not often updated regularly, and so the human person has to still try to monitor what's going on and fill in the gaps. And ultimately, to debug a system with automation in it, you need to understand the system overall and what the automation should be doing and how it's doing it wrong. But if you're just handed a run book, you know, how the heck do you know what's actually going on? It's fundamentally a more complex task than if the automation wasn't even in there to begin with. And this is my favorite quote from Dr. Bainbridge. So the more we automate, the more we need ourselves is the theory. This is what the research told us from airplanes, from cockpits, from nuclear power plants, from lots of places that have automation in them. Now, maybe we're different and special and better, but probably not. So we went looking in the void. Could we find evidence of automation and software and find some data on this? So the type of analysis that I did for this is called thematic analysis. It's an approach that's commonly used maybe more in like social sciences, but also just in domains that have heavily unstructured data, text-based textual analysis, right? And so it's a flexible process of identifying, analyzing, interpreting patterns of meaning or themes, hence thematic analysis, within qualitative data. So like I said, unstructured text, like, for example, incident reports. And the coding is thinking almost of like tagging for sort of similar items of text, not just individual words. So I'm not just looking for every time the word whatever shows up, but looking for chunks of text that kind of give you a sense of things that are, let's just say, phenomenologically similar, right? And then you begin to look for themes that evolve out of those codes. And the notion is, most people approach this by not having a set idea of what those will be. Sometimes you go in with a more very specific notion, but we wanted to just kind of open the floodgates and see what we could find by looking at the text contained in all of these incident reports. So effectively, you have all these qualitative data, you start assigning these codes, you kind of go back to the data, you're like, does that make sense? Does that look like what that is? And as you start to get the codes that you think you want, then you start to say, okay, well, these things seem to fit together this way, and then you sort of iterate back through that again. And so that's the general overview of what the process looked like. The first problem I had was, though, that I have 10,000 reports, more than that. And I am me, and I am primarily the void. And so I couldn't get through 10,000 reports in any time reasonably. But the next person asked me if I used like an MLL or the LLM. Sorry, my brain's not working right. You can talk to me later about that. No, I did not, but for reasons. So we reduced the sort of corpus of these reports using keyword searches for this sort of set of terms that were solicited from experts in complex software systems that include a lot of automation. These are people with like boots on the ground, day-to-day practitioner experience with these systems. I said, hey, what words should I go looking for? Because I had a few theories, but we added some of these to it. And there certainly could be more. This is not intended to be the world's most comprehensive view. This is a slice of a set of data that we have. But so we used keyword searches to reduce that down to a set of just under 500 incident reports that had these keywords in them. But then the next fun thing that we found out was within this, you could still have things that were products of those companies that failed. So you could have like, I don't know, I'm trying to remember, like a CI/CD. Like you could have a chef problem and chef like has a failure. So we had to kind of still go through the incident reports and then filter those out for where it wasn't just like a product having a problem, but it was actually automation in that report playing some role, okay? And so we're really looking for how was automation there? And when I started, I really didn't have any real ideas of what that would look like. But so we got down to that 459, and then we did this filtering of reading all of those and going, oh wait, no, that one's actually just literally saying that the chef CI/CD thing is the product isn't working. Okay, so then we get down to a smaller set of about just under 200 that we reviewed. And so this was coding, looking for a set of codes, going back, reading through again. Does this all fit? Is this making sense? The codes would sort of evolve a little bit as I was moving through it, but they tended to really solidify around this set of 6 roles or ways in which automation was showing up in incident reports, okay? And again, there's a lot of, and a public incident report is like 3 degrees separated from reality, right? And even though we know what reality is, right? So your mileage may vary there through that, but I'm going to take it as what I've got at the time. So the 6 ways in which automation was showing up as sort of coded behaviors in these incident reports was involved in the detection of an incident. So this one's not so surprising, right? An automated something kicks off and pages somebody, right? The other way was as a contributing factor to the incident. So your load balancer went, goofy, and then chaos ensued. Right? So it's actually a contributing factor in the incident happening. Hindering remediation is another one that I wasn't necessarily expecting, but it was like, okay, the automation's actually making it harder to figure out what's going on, or it's making the problem worse somehow. So this is sort of a cascading failure kind of scenario. Retry storms are maybe a really great example of that. Automation that might be involved in the solution, either as a part of it or it actually self-healed. It happens, or at least people tell me it happens. There's at least a few reports where people claim that the automation detected it and then it fixed it and then they all just moved on. But that's actually a really small amount. We'll get to the numbers. Manual intervention was required to get the automation to stop doing whatever it was doing that was making things problematic. And then the one that I really didn't see coming, but in hindsight makes sense, is automation as an action item to something to do after the incident is over. So in the incident report, here's what happened, we did this, and these are the things we're doing to make it better. And it's usually adding or changing or adjusting the automation. Okay. Is everybody with me? All right, here's the numbers. Let it be known that all of these could be involved in multiple ways in one incident. So none of these don't add up to 100. Don't come after me. You could have 3 of them in one incident. And in fact, I think 87% of the incidents had more than one role of automation in them. All right, but the number 1 was as a contributing factor. Automation was maybe not the thing, but one of the things that made things go sideways. You'll notice that detection, does this have a, I've never really used the little pointer thingies, does it? Oh, look at that. I feel like I'm back in college. Detection is low, I think. And I think that's just because not everyone says, our automated blah, blah kicked off and told us. So I suspect that number is actually a lot higher, but unless the report literally said that, then I couldn't code it as such. But so right up here next to causing a problem was us humans had to step in to fix it, okay? So 3/4 of the time, roughly, we're having problems because of it and we have to step in to fix it. And then 1/3 of the time, we're gonna do something more or differently with automation as a result of that incident detection. So then less than a fourth of the time, it actually is a part of the solution or is the solution itself. And then last but not least over here is the gremlin. I gave all of these things names, but yeah, I didn't really get into it here so much. 14% of the time, it actually makes it harder to get through the incident and to figure out what's happening. So if you remember only one thing from this talk, I really hope it's this. The vast majority of the time, in an automated system that we have designed to make our lives easier, we have to step in to solve that, and we often don't know what's going on. And then our efforts to deal with that automation sometimes, a quarter of the time spin out and get much worse. Okay. So there's sort of four themes that come out of this, okay? One, the first is that automation plays multiple roles in incidents, often in the same incident. So even though it's primarily developed to remove tasks from human oversight and alert us when issues arise and make our lives easier and make things faster and better, it frequently becomes a contributing factor in incidents without the capability to resolve those independently on its own. And so within a single incident, it's causing problems, we're fixing the problems, and it's sometimes making it worse. All right, second one. Oh, did I mention that it can sometimes make things worse? This actually became more of a theme than I really had realized. But not only does it contribute, but it actually aggravates the incident or makes it difficult to figure out what's going on. I think I already mentioned this, but like retry storms, interference with access to automated logs or data, unexpected interactions with other components that like expand the surface area of the incident, right? Or like your Facebook and you can't get into your own building. Does anybody remember that one? So it was a few years ago. So it can actually unexpectedly make things worse. This is another American movie. Sorry. I was realizing this as I was going through this. So the third big theme is that human intervention remains essential to resolve issues. The findings really illustrate how automation, which is designed to minimize human involvement, often necessitates human intervention when it fails to function as expected. And on top of that, these situations are usually more complex and challenging to resolve than the automation was designed to handle, and then the humans knew what to do with. There's no run book for that situation, and you could add it to the run book, but the next time it's going to be different, right? Okay. So it was just 3. And I really love the last one, that last scene. It's Tony Stark and it's Jarvis. And I guess I'm a fan of the series and whatnot, but I'm also a fan of the notion of the way that works. And so a lot of the folks who do research on these systems don't just like throw up their hands and leave and are like, good luck, right? They've got suggestions. They've got ways to think about this. And one of the terms that folks like David Woods and Holnagel and Richard Cook and folks and even Bainbridge and crew is this notion of joint cognitive systems. So it's a good sort of academic nerdy term that you can throw around at cocktail parties, but I like that a lot better because the notion is that we're doing this together and that we each have different kinds of cognition and they have to interact, right? Your automated system is an agent and you can see it as replacing you or you can see it as augmenting and making your life easier, right? So this is the Tony Stark, metaphor. But I think the expectation is we're going to have Jarvis, and the reality is we have like Waymo cars, interrupting traffic in San Francisco. So the reality is automation is commonly used for economic and temporal gain, right? To accomplish tasks more swiftly, more cost effectively than we think we can do by human effort alone. But it's a shortcut that tends to bite us in the long run. And it's hard to draw a clean line to that, to really illustrate the relationship. But the value of automation in software, it's extremely context-specific, domain-specific, implementation-specific, and focusing solely on short-term efficiency and profit can lead to an increased fragility in your system. It can actually counteract all those reasons we want to put automation in there in the first place. And so the question is, what do we do? What do you developers, what do we do? And product designers and engineers do? And the advocate what I'm advocating for and what other researchers in the field are is essentially a paradigm shift. So instead of perceiving automation, and as we just march down the road of AI as a replacement for human effort, we should view it as means to augment and support the work that we do. The goal is to transform automation from a unreliable adversary, a bad colleague, right, into a collaborative team player. So we're going to have an unfits list instead of a fits list, right? So let's get out of these fits style conceptualizations of automation and rethink what these relationships could look like. This is from, again, David Woods and colleagues. I think I might have the citation later. It's their unfits list about the competencies of humans and machines and how we can enhance those through sort of intentional forms of mutual interaction. And this is probably one of the most text-heavy slides I have. And I'm sorry, please take photos and you can watch this back in the end. I want to make sure we have enough time for Q&A. But I think the most important part of this is noting that machines in particular, they have low sensitivity to context and an understanding of change. And it's what these researchers in particular call ontologically limited, right? Like it's within the context of their understanding of their world, right? And they need people to do all these things to align to that context, to keep them stable, to repair those ontologies when they don't match up with what reality, and kind of keep the machine's models aligned with the world. And people are sort of the opposite. We have high context, we're adapted to change, it's very high adaptability, we're very goal-driven, we have all these other ways of dealing, or aware of the fact that the model of the world is the world, right? And so we can create machines to do these things instead, and thinking about this in a different way, right? So these are kind of the 10 aspects of that. I'm not going to go through all of this because I really want to leave enough time for questions. But I just want to put these ideas in your brain to think about how, if we're designing systems, if we're designing automation, if we're designing dashboards, how can we think about that in a different way? Can we, at the very least, have your own paradigm shift, right? Crack out of that mental model of that, the haba maba, and how do we design systems that actually help us do the work that we want to do better? And so I really think that one of the most important ones in here actually is, well, there's a couple. Agents must be directable, and I think that's something we don't design for very much at all in our automated systems. And agents must be able to engage in goal negotiation. I would love to hear if anybody has any ideas about what that looks like in your environment. And agents here are both humans and computers. But how do we make trade-offs? And how do we understand what those trade-offs might look like? Like if I turn this thing off or if I throttle this thing down, what's going to happen? And can we actually understand what that's going to look like? And then the other one at the end, this is a whole other world of things. I definitely encourage you all to look up Dr. Laura McGuire's research on costs of coordination in incident response. But one of the factors is you're in that high tempo, high pressure situation where everything's going sideways, and having systems that aren't doing what we want, or we can't introspect them, or we can't tell what's happening, actually increase what's called the cost of coordination, right? Making it even harder. So they become, and I mentioned this term earlier, bad team players. And how can you make those actually something that doesn't add to that cost of coordination when you're in the situation of trying to resolve an incident? So these are for thought. I don't have really great examples of these in our domain yet because I don't know of anybody who's done this yet. So this is my my hope and my challenge is that we'll see more of that going forward in the sort of the tooling and the options that we provide each other. And that's the end.